All right, so today we are going to do a review of the three main properties for differentiation. So you can see this screen capture of the differentiation section of your IB Math SL formula booklet. I'm assuming you have good command over these rules right here. Those are just the basics. You just follow how it's written. Differentiating sine of x gives you cosine of x. Differentiating cosine of x gives you negative sine of x, etc. Where things get more complex is with looking at the chain rule, the product rule, and the quotient rule. And all three of these have to do with when we don't just have a single power property or trig function or e to the x or ln of x, where we might have e to the x times sine of the x. Sine of x, or you might have e to the x divided by sine of x. So my first example was a product, my second one was a quotient. The other kind is chain rule right here, which is super important because it shows up all the time. And if you forget to use chain rule, this is true of all of the rules, but especially with chain rule, it's very easy to forget. It's a little less obvious, and every time you forget, that's gonna mess up your entire work all the way through going forward. So the time that you are going to use chain rule is anytime this isn't just sine of x. If it's sine of anything but just x, or a different variable, sine of t, sine of p, whatever, anytime it's not just x, so let's say it's sine of 2x, or sine of 3x minus 1, or sine of x squared, anytime it's not just a singular variable right there, that's when you're going to use chain rule. And that's true of any single one of these. Anytime this x that's in this formula is not just x, if it is anything other than just x, you're going to have to use chain rule. Product rule, like I said, it's a little more obvious to us usually. That shows up anytime you're multiplying any two of these, so or more. So if you're multiplying sine of x times x squared, or you're multiplying ln of x times e to the x, or so on, you're going to have to use product rule. Quotient rule, again, also a little more obvious because we're talking specifically about dividing. So sine of x divided by e to the x squared divided by cosine of x, you get the idea. So let's look at how to apply these. All right, so we're going to look at this first example, and there are two parts to this question. At the beginning, it just asks us to find f prime of x, so it's asking us to differentiate. And when we look at this, we should see a big clue. We don't just have x squared or sine of x, we have the product of both of them. So that is our clue that we're going to use the product rule. So the first thing I recommend doing, regardless of how good you are at just jumping right in to solving these kinds of problems, is to write out the rule in its entirety. People always want to think that they can just skip that step because they're good enough to. And even though that may be true, if you make any mistake, you might not get your full points. And one of the very first method points on problems like this is often it says M1 or M2 for identifying and attempting to use product rule. So you want to show them that you are attempting to use product rule by writing down what product rule is. The second thing you're going to do is you're going to have to identify what's your u and what's your v. With product rule, it doesn't matter which order you go into. You just need to label one of your functions as u and the other as v. So we have the product between x squared and sine of x. So one of those becomes u, one of them becomes v. The next thing we're going to do is differentiate each of those functions individually. So I'm going to find out what is du dx, the derivative of of x squared, which is 2x. And then I'm going to differentiate v, so dv dx. What is the derivative of sine of x? And we know that's cosine of x. Now, what people often do from here is they accidentally just multiply both derivatives, but we know that's not true, Because if we substitute directly into this formula right here, that's not what we're going to get. So this formula says dy dx, the derivative of y in terms of x, is equal to u, which we know is x squared, times dv dx, which we know is cosine of x, plus v, which we know is sine of x, times the derivative of u in terms of x, which we know is 2x. And I recommend always putting those x parts of the term at the front so you don't accidentally try to mesh it with the inside part of your sine function. So writing it like that usually can help. So that's our derivative. We can't simplify that anymore. We cannot multiply x squared times x and make that cosine of x cubed. Order of operations would say first we have to evaluate cosine of x, then multiply by x squared. So we can't simplify this any further. Okay, then the second part of this question asks us to find the gradient of the curve at x equals pi over 2. So we know that gradient comes from our first derivative because our first derivative can sometimes be called the gradient function. It tells us our gradient at any x value. So we can just go ahead and plug in pi over 2 for x. And this is where our trig knowledge comes in. We have to be able to simplify this. So what is cosine of pi over 2? Just a reminder, pi over 2 would be straight up right here. So the x value would be 0. So this becomes 0. And so this pi over 2 squared, that part times 0 is just going to entirely cancel itself out. We know 2 over 2 would just be pi. And sine of pi over 2, that's the y value of this ordered pair right here. We know that that would be 1. So pi times 1 is just pi. That's the slope when x is pi over 2. Okay, so we just did an example that was a product property. Let's go ahead and look at another kind of example. And so we're going to start with part A. When we look at it, we should be able to identify, again, it's not just one single type of function. We have a function 6x divided by a different function, x plus 1. So that should be our clue, since we're dividing, that we're going to be using quotient property. Just like before, the first thing I would do is write out your quotient property rule. Again, that's just to be very explicit so that IB knows exactly what property you're using and that you can earn those points for using the correct property, or at least attempting, even if you make a mistake somewhere. And so this is just coming straight from your formula sheet. Once you write down that quotient property, then you're going to label u and v. And unlike before with the product property, it does matter which one is u. U has to be the numerator, so u has to be 6x. And v has to be the denominator, so v has to be x plus 1. Just like before, we're going to differentiate each of these individually. So we're going to find du dx, which is 6, and dv dx, which is 1. And then we're going to go ahead and plug straight into that formula. So first it asks for v, so that's x plus 1. Then it asks for du dx, which we know is 6. Then it asks for u, which we know is 6x, and then dv dx, which we know is 1, all divided by v squared. And so we're going to simplify as much as we can. I'm going to distribute that 6, so that becomes 6x plus 6, and then 1 times negative 6x is negative 6x, divided by x plus 1 squared, and we know 6x minus 6x is 0, so we get 6 over x plus 1 squared. And because they didn't specify the format, I don't see any reason why we would have to FOIL this x plus 1 out. although it certainly would not hurt if you had decided that you wanted to. But I think we could just leave our answer like that. Okay, and then looking at the second part, it tells us that g of x is equal to ln of 6x over x plus 1, and it asks us to show that the derivative equals 1 over x times x plus 1. So hopefully you're making the connection that this 6x over x plus 1 is this other function that we already differentiated. So this is the exact definition of the chain rule. When we have this function, this other function, inside a different function, the ln of x function. So we have a function in a function. That should ring your bell talking about composite functions, right? A function in a function. And so chain rule, that's exactly when we use our chain rule. So when we use our chain rule, I'm going to start by writing down that formula just like before. It's written like this, saying we have this function g and we have this other function u inside of it. So it labels u as f of x, this other function that's inside. And then it tells us that dy dx, so the derivative of y in terms of x, equals the derivative of y in terms of u times the derivative of u in terms of x. So there's our chain rule formula. So the very first step is to identify what u is going to be. And u is the inside function. It's the function where, it's the function that's in your other function. So on the inside, this is our function that's on the inside. So I'm going to label u as 6x over x plus 1. So that means that my function y, because I'm going to just make that y, is now ln of u. Okay? So, once I identify what my u is, and then I rewrite my equation y in terms of u, then I'm going to differentiate both of them. So I'm going to differentiate u in terms of x. The good news is, hopefully you recognize that we already did this in the last part, so there's no reason to recreate that. We already know that it's 6 over x plus 1 squared. And then we're going to differentiate this y in terms of u. So the derivative of ln of any variable is just 1 over that variable, so that's 1 over u. And so now we can substitute directly in to that formula. dy du is 1 over u. du dx is 6 over x plus 1 squared. And the last thing I have to do is I have to get rid of that u because we don't want it left in there. And so we already labeled u as being 6x over x plus 1. So now we have it set up for our derivative. We just have to keep simplifying. So when I divide 1 by 6x over x plus 1, that essentially takes the reciprocal. Now, hopefully what you're noticing is that dividing, when you multiply straight across, you're going to be dividing 6 over 6. Since it's all multiplication, we can just cancel those. And so then that gives us x plus 1 over x times x plus 1 squared. And hopefully that we can recognize that x plus 1 squared would be the same as x plus 1 times x plus 1. The reason that helps us is that one of those will now cancel. And when you divide that, it equals 1. And so that leaves us with this as our derivative. So when you're looking at chain rule, it's very important you start by identifying the inside function, and then so you identify that as u, and then you write the equation with u instead, and you differentiate both of them, and then you're essentially multiplying those. Okay, so here's another good one. I might go ahead and pause this and give it a try yourself, but if you're not sure, I'm going to go ahead and work through that with you right now. So this is another good example of one of those properties. Hopefully, as you're looking at it, you're noticing that instead of cosine of x, which is what we normally might see, we have this other function, e to the x, inside of it. So this is your classic function in a function. So that means we're talking about chain rule. So again, we've got to identify u. That's the inside, so that's e to the x. And then we have to take our function y and replace e to the x with u. So that's our first step. Now again, I'm going to make sure that I write down dy du times du dx. I'm going to make sure that I start by writing down my product rule. That is just, a great way to make sure you're earning your points. So all I have to do is find out what this is. What is du dx? Well, we know the derivative of e to the x is e to the x. What is the derivative dy du? So the derivative of cosine we know is negative sine of u. And then we substitute on into that formula. So dy du is negative sine of u, and du dx is e to the x. And we just have to make sure we don't leave u as a part of that. And so we get that. And I, again, would just recommend putting that e to the x at the front so that we don't try to confuse it and combine it with the e to the x that's a part of the sine function. And that is our solution right there. That's the derivative. One quick note, sometimes people see this and they want to do the product rule, but be very careful with that, because what we have to notice is that this is not the product of cosine with e to the x. If it was, it would have to be written like that, cosine of a variable x times e to the x, not cosine of e to the x. So just a very careful note that this is not a product rule, this is a chain rule, because we have the function inside the cosine function. Okay, so looking at this, hopefully you have a good idea of what rule you might use. We have to use a rule because it's not just a straightforward 2x or a straightforward sine of x. So I will give you a second. Go ahead and pause the screen and give this one a try. And I will go ahead and work this out. So hopefully you've noticed that we have the product of two functions, one of them being 2x and the other being sine of x. So that is our product rule. And I'm going to go ahead and write it. I know it's a pain to write this every time, but if I haven't emphasized it enough on this video, it is worth your time. Okay, so there's our product rule. So we need to find what is du dx, which is 2, and what is dv dx, which is cosine of x. And then we need to substitute on into the product rule. U we already know is 2x. dv dx we already know is cosine of x. V we know is sine of x. And du dx is 2. I can't emphasize enough, and I don't actually think I have emphasized enough, that the biggest key to these problems, besides always writing which rule you're using, is to keep very clear labels about what it is you're doing. If you are someone who is, while they are working, not writing du dx or dv dx because you're intimidated by that as a symbol, or because you're like, oh, it'll be fine, I don't need that, I'm just kind of scratching out my work and making sure I just calculate these derivatives, but I don't really need to label them, you're going to make mistakes. And you're not going to fully understand it. So make sure that you are keeping very careful, step by step. Your grader can't give you points for everything you know if you don't do a good job of very clearly indicating your work. And just like before, again, we don't want to get confused and think that that's sine of 2x, because it's not. It is 2 sine of x. The x is a part of the function, the sine function, whereas the 2 is not. So I'm going to rewrite it like that. So there's our derivative g prime of x. And then it asks us to find the gradient when x is pi. So that's asking us to find g prime of pi. And so everywhere we see an x, we're going to replace it with pi. We know that pi is right here, so that cosine is x, so that's -1 at pi. Sine is 0 at pi, because that's y. So this gives us -2 pi as our gradient when x is pi. This would be another good slide to pause and give it a try, and then hit play when you're ready to see the answer. So there's 3 parts to this question. Okay, so when we are looking at the very first part, it is asking us to find f prime of x. So they've given us that f of x is cosine of 2x. Hopefully when you're looking at this, you're recognizing that we have a function 2x inside of the other function cosine, and so that is a chain rule. So the first thing I would do is write down your chain rule property. dy dx equals dy du times du dx. That's a y right there. And we know it's chain rule because we have this function 2x inside the other function cosine of x. One common mistake is that sometimes people want to try to make this a product of 2x and cosine, but cosine itself is not something that can stand alone. Cosine is an operation on something, so it can't just be cosine. It would have to be cosine of x times 2 of x if it was going to be a product property. It would have to look like that if it was going to be product. So this is not a product property one. So it's chain rule. We have 2x, a function inside the function cosine of x. So that means that inside function is 2x, and that makes our original function cosine of u. And we need to find the derivative du dx, which is 2, and the derivative dy du, that's the derivative of y in terms of u, which is negative sine of u. And then from there, we can just substitute in to this formula here. So we get dy dx equals dy du, which is negative sine of u, times du dx, which is 2. And again, I would always make sure that you make that 2 sit in front like a coefficient. And then we have to replace u with what we defined u to be, which is 2x. So that is our derivative f prime of x. Okay, so that was our chain rule for f of x. For g of x, they also want us to find g prime of x for part b. So same idea, when we are looking at this function g of x, we see that there's a function 3x minus 5 in the function ln, so natural log. So again, we're going to set u to be that inside part, 3x minus 5, and that leaves our function y as just ln of u. Just like before, make sure you are writing out that chain rule every time. So this is another chain rule property or problem because we have the function inside the other function. So our next step is to find the derivative du dx, which is just 3, and dy du. We know the derivative of ln of a variable is just 1 over that variable. And so we can go plug in into our chain rule formula. So dy du is 1 over u. Du dx is 3. So that becomes 3 over u. So our first derivative is 3 over u, but we can't leave it as 3 over u. We have to replace u with what we defined it as in the first place. So that's 3x minus 5. Okay, so then from there, our last part is defining this new function. Again, this is something that we see a lot in IB questions. It's defining h of x to be f of x times g of x. So there should be a big clue here that we're using chain rule because we literally have this function f of x times this function g of x. So we have a product of two functions. We have to use chain rule. So I'm going to go ahead and define u to be f of x and g of x as v. So u is f of x, v is g of x, because it's going to have to be a product rule. And that way we know that the derivative h prime of x will be u times dv dx plus v times du dx. So when we want to find du dx, that's the derivative. Well, the derivative of f of x would just be f prime of x. And when we want to find dv dx, the derivative of g of x would just be g prime of x. And so we can go to plug this in directly into this formula. So instead of u, we can replace that with f of x. And instead of dv dx, we can replace that with g prime of x. Instead of v, we know that that's g of x. And instead of du dx, that's f prime of x. So to find that derivative, h prime of x, we have to do the product rule because we have the product of two functions, f of x and g of x. And that's what we're going to get. Now, we're not done until we substitute. But the nice part about this problem, as IB likes to do, they have guided you towards this entire process. So we know that f of x was cosine of 2x. We already found g prime of x to be 3 over 3x minus 5. We know g of x to be ln of 3x minus 5. And then we know f prime of x is negative 2 sine of 2x. Now, there's not actually really a whole lot of simplifying we can do on this. In fact, there's really not almost any simplifying we can do here. So you could just go ahead and put a big box around that, and that would give us our answer. Okay, one more problem for you to try. Go ahead and pause the screen and give this one a shot, and then take a look when you're ready to see me work it out. So, looking at part A, they want us to find f prime of x and g prime of x. We should notice as we're looking at this that both of these are chain rule problems because we have the function negative 3x in the function e to the x. So again, anytime it's not e to the x, it's e to anything that's not just x, we're going to have to use the chain rule. Same thing here, we're going to have to use the chain rule because it's a function x minus pi over 3 inside of the other function sine of x. So again, two chain rule problems. So we may just want to start out by writing that chain rule formula up at the top because we're going to be using it twice. And so when we look at f prime of x, we need to start by saying what is u going to be. That inside function is negative 3x. And so that means y is just e to the u. So when we differentiate, du dx is just negative 3. dy du, well, the derivative of e to the u is still just e to the u. And so looking at our chain rule formula, we substitute in. So our derivative, f prime of x, is going to be dy du, which is e to the u, times du dx, which is negative 3. And we have to, I would write negative 3 as the coefficient, and I would also replace u, we have to replace u, with what we had defined it as, which was negative 3 to the x. So hopefully you're noticing that we have the derivative e to the negative 3x times the derivative of the negative 3x. That's that part right there. So that's our chain rule. For part 2 of the same question, we're going to do the same idea. We're going to define u as that inside function. And that means that our y is just sine of u. And then when we differentiate du dx, well, the derivative of x is just 1. And the derivative of negative pi over 3, that's just a constant, so that's 0. And the derivative dy du is cosine of u. And again, we're going to substitute into that chain rule. So that gives me g prime of x is going to be dy du, cosine of u, times du dx, which is 1. And so that just leaves us with cosine of u, and we know u is x minus pi over 3. Now a quick tip on IB exam. You might be saying, well, if I had forgotten to do chain rule on this problem, I would have still gotten cosine of x minus pi over 3 since this differentiated to be 1. And you're correct, you would have still ended up with the right answer. It would have been a coincidence. That's not how you would be able to actually do it. But a lot of times with the IB grading, the first point is a method point, and it's a method point for recognizing that you're supposed to use the chain rule. And if you don't get the first method point, you can't get the following accuracy points. So you may not be able to get any points, even though you inadvertently ended up with the same answer as the correct answer. So make sure that you're always making very clear that you're doing the chain rule if you're doing the chain rule. Okay, and then we can go ahead and look at 6b. And it says, let h of x equal e to the negative 3x times sine of x minus pi over 3. Find the exact value of h prime of pi over 3. This problem should look very similar to the last problem. What we notice here is that we have a product property because we have e to the negative 3x, a function, times this other function, sine of x minus pi over 3. And hopefully you're recognizing that you already differentiated each of these separately, which is going to be a big help to us. So anyway, let's go ahead and write out the formula for the product rule, which is dy dx equals u times dv dx plus v times du dx. And then we're going to set our u and our v. So u is e to the negative 3x, v is sine of x minus pi over 3. When we go to differentiate du dx, hopefully you're not wasting your time redoing it. We did it right above here in part A, so hopefully you're just pulling that on down from part A. Same exact thing with part B. We already did it, so hopefully you're not spending your time redoing it. And then we're going to substitute into the product property. So we know that h prime of x is going to be u, e to the negative 3x, times dv dx, which is cosine of x minus pi over 3, plus v, which is sine times x minus pi over 3, times du dx, which is negative 3e to the negative 3x. And then our next step is to, because we found the function, but we haven't found the derivative at pi over 3, so we are going to substitute in. So that gives me e to the negative 3 times pi over 3 times cosine of pi over 3 minus pi over 3, so that's cosine of 0, plus sine of pi over 3 minus pi over 3. Well, again, pi over 3 minus pi over 3 is 0. So sine of 0 times negative 3e to negative 3 times pi over 3. And we have to evaluate at 0 degrees, or 0 radians. That's where it is. Cosine is 1, but sine is 0. So when you multiply 0 times that whole thing over here, that's going to cancel that part out, which is nice. And negative 3 times pi over 3 would be negative 3 pi over 3. And so, like we said, this part over here has canceled out because of the 0. We know anything times 1 is just itself, so we are just left with e to the negative 3 pi over 3, which is just e to the negative pi. And that's our final answer. Okay, so that's all for this review. If you want to do some practice problems on differentiation, all of your basic rules for differentiation are in Chapter 12, and that's for your differentiating trig, exponential, and natural logs. You're differentiating from for the power rule. And then if you are looking at using product rule, that's 14b, quotient rule is 14c, and your chain rule is 14a. So that's where you can look in our Cambridge Math SL book for some extra practice.